Well, here we are at section 5.6. So we're going to throw everything that we've been looking at with logarithms and exponential functions together because now we're going to start solving some good equations with these. So let's see how they go. So we're going to solve and then we're going to check for the extraneous solutions. Now the extraneous solutions, those are really going to only occur with any logarithm, because the exponentials, they don't really have, I mean, you can usually plug whatever you want into them. The domain was typically all reals, but not for the logs. So we're going to have to check those when we come to them. All right, so this one's just going to be kind of easy. You have log base 5 of 2x plus 3 equals log base 5 of 3. So if there's a logarithm on either side, and that's it, if they have the same base, if the logarithms are equal, then whatever's inside of them should be equal. So like the log base 5s drop out, and we just have to solve 2x plus 3 equals 3, so x would equal 0. And then if you plug this back in for x, that gives you a positive number inside the log, so we can keep it. Okay, let's move on to this one. So same type of thing. Let's try to get it to look kind of like this. So I'm going to use that property where I can pull the coefficient up into the exponent. So log base 4 of x to the negative 2 equals log base 4 of 9. So now the log base 4s will drop out. And we just have to solve this. And there are a few ways you can go, so I'll show you one. That's not the only way, but to me it's pretty straightforward. Okay, so that negative exponent, what does it do? It flips it. So 1 over x squared is equal to 9. Well, now I can take the reciprocal of both sides and get x squared is equal to 1/9. I can square root both sides to give me plus or minus 1 over 3. So hopefully if you went with another direction, you would still get plus or minus 1/3, but we still have to check it. So we're plugging it into that x right there. So I can keep the positive 1/3, but if I stick in that negative, I have a negative inside the log, which means I have to toss out the negative 1/3. So I only have the one answer for these, or for this one. Okay. Part C, this one's a little bit different. Now you have two logarithms just like before, but they're on the same exact side and there's another term. So I can't do the exact same thing I just did with A and B. A and B are kind of unique. Most of the ones that you're going to encounter are going to look like this. So yeah, I can move this log over there, but I still have that extra 4, which means the logs will no longer drop out like they did here and here. So instead, I'm going to use a property. So that plus sign means I can change it to multiplication. So log base 2 of x plus 1 times x plus 7 is equal to 4. And now I can use, or now I can change it around to exponential form. And I'm going to multiply and FOIL this out at the same time. So that would be x squared plus 8x plus 7 is equal to 2 to the 4th, or 16. Well, now it's quadratic. So, oops. Set it to 0. And use any method to solve it. So with this one, let's go ahead and factor. So x, x plus 9 and x minus 1. So x is going to equal negative 9 and 1. So I have to check them. So if I use that negative 9, in here or in here, it gives me a negative result, so I got to toss it out. So I can only keep the positive 1. Okay, so this one's kind of similar to the previous example, but it has that minus. So what does the minus do instead of the plus? That's right, it turns it into division. So now you have 5 plus 2x over 4 minus x, and that's equal to 3. So you can end up with some crazy looking logarithms, which is fine. And then once you use the properties and combine them, then you can change it to exponential. So you have 5 plus 2x over 4 minus x equals 2 to the third, which is 8. So now you can pretend that's over a 1, and then you can just cross multiply it. So 5 plus 2x equals 32 minus 8x. So 10x is equal to 27. So x is equal to 27 over 10. And if I take this answer, stick it back in for x, it turns out to be a positive result in there, so I can keep it. All right, let's go ahead and pause here so you can kind of reflect on those for a moment, and then I'll finish the rest of these in the next one.